ready to start, so I will introduce our speaker in about 1 minute. Thanks for your patience, and we're really happy that you're joining us tonight. Okay, CSI fans, we have the real thing for you tonight, and we're also going to do something a little bit different this evening. We are going to ask you to actively participate in this webinar. I hope you find it interesting. Good evening to everyone. I'm Kent Mortimer from Core Justice, and I will be your moderator for this webinar. This webinar is one of a series of legal education webinars co-hosted by USAID's Core Justice Project and the Colombo Law Society, with the strong support from Colombo Law Society President, Mr. Vijaya Gamage, and committee members, Mr. Binara Gunasekara and Mr. Niroshan Siravardana. Core Justice supports the strengthening of skills and knowledge of members of the legal profession, working with counterparts like the Colombo Law Society. Remote learning opportunities such as these webinars mean a wider and more diverse audience, which we hope will lead to a good question and answer session at the end and as we proceed during this webinar. The Colombo Law Society was established in 1975. It is the largest branch association of the Bar Association of Sri Lanka, with close to 4,000 life members representing the civil, criminal, and unofficial bars and the judiciary. The Colombo Law Society makes a vital contribution to the legal fraternity by furthering its skills, knowledge, welfare, and independence. That's a commitment reflected in the Colombo Law Society co-hosting this webinar with Core Justice. A couple of notes about the presentation. The lecture session will be approximately 1 hour in length. Your microphones will be turned off during the session. I'm sorry about that, but the good news is that you may send in questions at any time during the session, in English if you would, via the public chat option. And if you look at your screen, you'll see that option up toward the top on the left-hand side. If you click on public chat, that opens the box, and I think it probably is pretty easy once you do that. I will present some questions to Mr. Kara, our presenter, at the end of the presentation, although I will tell you that he will be watching your questions as he proceeds, so please feel free to add your comments as we go. One other technical note, you can have a full screen if you press the 3 dots, and the 3 dots are on the right-hand side up toward the top, and one of the options is to select a full screen, so feel free to do that. If you have any technical problems, please contact the technical resources specialist. You have those contact details. They were sent to you earlier. Now let me introduce to you the resource person for this webinar, Mr. Kara. He joins us this evening from Ankara, Turkey. And you'll see a picture of him on the slide in just a second. I'm sorry, I'm waiting for the slide to be changed. Mr. Kara is a forensic expert with over 20 years of experience. He holds a Bachelor of Science degree in chemistry and a master's degree in human resources development. He worked at the Turkish Police Department's forensic laboratories at various positions where he practiced and supervised forensic investigations. His areas of expertise include crime scene investigation, fingerprint identification and development, automated fingerprint identification systems, forensic laboratory accreditation, shooting reconstruction, and criminal investigations. I will now hand over to Mr. Carr the floor to start this webinar, which I'm sure you will be very interested in seeing, and I can tell you that I'm looking forward to seeing his presentation. Mr. Carr, welcome to Sri Lanka, and good evening to you, sir.
Thank you, sir. Thanks for having me. I wish a nice 1-hour webinar to all of us. Thank you. Okay. Hello, everyone. My name is Erdem. Good evening. This is the second webinar in line we're making about forensics. This time it's about fingerprints and identification and AFIS, a system that is that automizes our identification process. This webinar, after the introduction, we're going to make a short quiz. It's sort of knowledge check and to give you a better understanding of what we are going to be covering in the coming slides. Okay. Right. So the goal and objectives of this webinar is to share information on one of the oldest criminal identification method and evidence, fingerprints, and to familiarize participants with concepts and terminology that they will encounter at forensic reports in relation to fingerprints during criminal cases. As we know, fingerprints are one of the oldest and mostly widely used evidence, especially in criminal cases. Legal society is going to see some fingerprint evidence as a matter of identification. So the purpose of this webinar is going to share knowledge with you that you will be familiarized with the concept of fingerprints, how they are used for the identification purpose, and what are the differences of fingerprints that make them unique. We're going to speak all about these. So the first point is the value of fingerprints in criminal cases. And then we will discuss, talk about types of fingerprints and how fingerprints are recorded. Identification through comparison. Obviously, we are talking about fingerprints as a matter of identification and how they are becoming unique, what makes them unique. And then we will talk about automated actually fingerprint identification system, which in abbreviation we call it AFIS. And lastly, we will speak about the techniques for developing latent fingerprints. I would like to underline that this is not meant to be a highly technical fingerprint presentation. The purpose of this presentation is to equip legal people with the need to know based information about fingerprints, as it may come before you in the criminal cases. Last point, especially I wanted to mention the techniques for developing latent fingerprints. In a law enforcement report, in a forensic report, you might encounter saying that evidence recovered from the crime scene has fingerprints on it, and the method of development is blah, 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 A, B, C, or D. So the purpose here is to give you an understanding what that method is and how it is utilized, how it is made use to develop fingerprints. Okay, in the beginning, we have a question. Actually, we are going to have 4 questions that we're kindly asking you to mark. In a minute, you will see the options A, B, C, or D. One technical issue that I want to mention: you're not going to be able to change your answer. So once you mark one of your choice, once everyone marks, I will then share the answers, and we're going to discuss about the correct answer. Okay, so I'm just going to read the question and then give you some 30 seconds or 1 minute. Question number 1: which of these is a name given to the examination of fingerprints? A, entomology; B, trichology; C, palynology; D, dactyloscopy. So, yes, you are now good to mark your answer. Right. We have 66 participants, and 33 of the 34 and increasing of the participants have marked already. I'm going to give another half minute. Which of these is a name given to the examination of fingerprints? Okay, we have as of now 39, 40 answers. 42. Okay, here are the answers. I'm just publishing them. Good. We have answer A, 7 people, answer B, 5, answer C, 7, and 26 participants chose dactyloscopy as the answer. So let's have a look which one is the answer in the next slide. Yeah, the correct answer is D, dactyloscopy. It actually comes from the Greek words dactylos, meaning finger, and scopein, meaning to examine, which means examination of fingerprints. So the correct answer is dactyloscopy. It's just as a side information, because these are also related to forensics. Entomology is the study of insects. You might be wondering how it is related. It's obviously not the topic of this presentation, but entomology is also used, is a branch of forensic science, can be utilized in the forensic science. By looking at the insects, worms, it is possible to understand the time elapsed after death, or if a deceased body brought from another location and put to that location, with the fact that each area has its own flora of insects. Okay, well, obviously the next ones are clear. Study of hair, and palynology is the pollens and spores. All right, good. We have a high rate of correct answers. So here's the next question. Okay, I'm going to read it for you. And at the same time, let me start the survey. Okay, what causes fingerprints to be left behind when we touch things? A, the smoothness of the surfaces we touch. B, the natural oils in the skin. C, the moisture in the atmosphere. D, the dust on the things we touch. Obviously, when we touch, our fingerprints are deposited on the surface. So what causes this? is the question. Fingerprints to be left behind when we touch things. Right, we have 73 participants and 48 answers, 49 answers. Quite a good number. Okay, we are above 50 now, 54. Yes, I am now publishing the answers. Here they are. Right, we have 15% A, 65 B, 13% C, and 7% 4 answers. What is B? The natural oils in the skin is the answer. Let's look at the correct answer. Yes, it is B. The skin's sebaceous glands produce natural oils, which, together with the salts produced by our sweat glands, leave a fingerprint residue when we touch most objects. We will be covering this during the presentation. We call it a fingerprint residue, actually. All right, here is the third question. Let me put, yes. Question number 3. At what age do human beings acquire fingerprints? A, at 6 months gestation. B, at birth. C, at 3 months gestation. D, at 2 weeks of age. So the question is, human beings acquire fingerprints when? Again, this is also a topic that we are going to be discussing during the presentation. So we have 43, 45, 47. Okay, we are above 50 now, 52. Good. Let me publish the answers. Right. We have a 30% saying A, 35% saying B, 21% 12, and 14% saying D. Answer D. So let's look at the correct answer. The answer is C. The human fetus acquires fingerprints at 3 months gestation. Again, this is a topic we will be discussing, and the point of this question is to share you the knowledge that they start forming and during the phase, even before delivery and at the 3 months gestation period. Right, here's our next and last question. Let me start. Yes. Question number 4. Which of the following statements about fingerprints is not true? A. Fingerprints are unique for every human being. B. Fingerprints of a person will start changing at the age of 13. C. Even identical twins do not have identical fingerprints. D. Fingerprint patterns do not change with growth or age. Right. Well, okay, we are above 50, 55 now. And let me share the results with you. Okay, it's increasing. We are 60 now. Good. Right. A high percentage says B is the answer, which is fingerprints of a person will start changing at the age of 13 as the incorrect answer. Yes, so let's have a look at the answer and then we will start our presentation. Yes, fingerprints are unique and do not change by age. So incorrect answer is B, as most of you have correctly marked. Right. Okay. Here we are starting our presentation. Identification through fingerprints. Obviously, establishing the identity of a suspect. By the way, thank you for joining the short quiz and participation and marking the answers. Identification through fingerprints. In our previous webinar, we talked about the crime scene and how important physical evidence are. Obviously, fingerprint is one of the most important physical evidences. And what makes fingerprints that important? The most positive means of identifying people is through fingerprints. So it helps us, it helps the law enforcement to identify a person. Fingerprints form on a person before birth and remain unchanged throughout life. Except for a few exceptions, everyone has fingerprints, and in this webinar, the term fingerprints includes all types of prints, including finger, palm, toe, and the sole of the foot. All right. As you can see, this is about two zebras here. The idea is like fingerprints. Everything in the nature are not same and unique, and the marks on the zebras are not same as well. So another point here is identical twins. Identical twins do share the same DNA. However, they do not share the same fingerprints. Right. Why do we use fingerprints? Because they are unique. No two people have the same ridge formations. What is a ridge formation? We're going to be discussing that. And they are permanent. They form prior to birth and never change. One of the great things about the fingerprints is that they okay, I'm trying to open the chat box. Okay. So one of the features of fingerprints that makes us use them is that they can be classified. They can be given a number for personal identification. Okay, just a short history. I tried to make it as short as possible. The purpose is to give you a better understanding what are fingerprints and what was the need for the fingerprints. So in 1870, there was a system called Bertillon system. A French anthropologist devised an identification system that recorded the dimensions of certain body parts of the body. So basically what they were doing is they were measuring the distance between two eyes, the hands, and other parts of the body, and for identification purpose. What happened later is in 1904, a person was taken into penitentiary with the surname West. A man named Will West was received in Leavenworth prison. On examination of his Bertillon measurement, it was found to be the same as another individual named William West, who was already incarcerated at the same prison. So it was an interesting thing that they had two different persons with the same measurements, Bertillon measurements. What they did is later on they looked at their fingerprints. The fingerprints were compared, and the differences were obvious. and it was easy to distinguish the two people. So here we have West brothers. The history is long. I'm not going to mention, but it says that they were separated when they were babies, so they did not know each other, and they even didn't know that they have an identical twin brother. So these are West brothers. This is how they look differently on two different photos, and here are their fingerprints. As you can see, these are the thumbs. The one on the left and the one on the right are different. How they are different, what makes them different, we are going to look in our presentation. So later on in 1892, Sir Francis Galton, and he's also called the father of fingerprinting, published a book on fingerprinting, first identified rich characteristics that assisted Britain changing from the Bertillon system to fingerprints for identification. And then we have a person called Sir Edward Henry, 1893, devised the Henry classification system, which is still in use today. Right. That was it for history. I hope you didn't get bored. So the value of fingerprints, where does it come from? Each person has unique skin and ridge patterns. Skin and ridge patterns are unique to each person. Therefore, everyone has a set of identifiable patterns. And these patterns can be examined to produce an identification that is indisputable. No two individuals in the world have the same fingerprints. Not only are an individual's characteristics unique, but the pattern never changes from birth to death. There is a word here that might have caught your attention, which is indisputable. At the end of this presentation, I added a link. In that link, it gives you a connection to a case that was in the United States. A judge called Judge Pollack, he was challenging the fingerprint evidence. So because our target audience, main audience here are the legal people, I just took this example. The fingerprint evidence was challenged, and then the forensic experts were there to explain the scientific base on the fingerprint evidence. The judge, strangely enough, has reversed his decision. I included the link, so I recommend to have a look at this case. Okay, the second feature of the fingerprints are that the characteristics about the person who made them. To a certain degree, fingerprints may also reveal characteristics of the person who made them. What is an example? For example, the hands of a bricklayer or construction worker may reveal calluses and wear, while the hands of an office worker may be without blemish. These observations are merely in addition to the basic fingerprint pattern. Just, I would like to underline this point. It is an addition to the basic fingerprint pattern and only enhance the uniqueness of the person's fingerprints. Scars, deep cuts form a characteristic as well. Okay. Only one person can make a given impression. Fingerprint evidence differs from most other evidence in that only one person, to the exclusion of all others in the world, can make a given impression. It is the uniqueness of the fingerprint that establishes beyond a reasonable doubt that a particular person made that fingerprint. To date, no two persons have yet been found to share a common fingerprint pattern for even one print. Okay, well, we talk about fingerprints being different, how they are, and not two person on Earth have the same fingerprint, and how this is possible. What makes us say that, we're going to see at the rich characteristics part of this webinar. Right. So talking about fingerprints, another classification of fingerprints are we classify them as latent fingerprints on their deposited on different types of surfaces. So latent fingerprints are invisible impressions that are left by persons and can be deposited on a variety of surfaces. So the latent fingerprints are the most common fingerprints that are used in the fingerprint area and fingerprint identification. Obviously, when we touch a surface, for example, again, this glass, when I touch it, I leave my fingerprints on that surface. And referring back to the first presentation, every touch leaves a mark. And remember Lockhart's theory of transfer. When we touch, we leave a mark. And the main purpose of the forensic science is to find that evidence, even if it is invisible, and latent prints are invisible, to make it visible and use it for the identification purposes. So this is called forensic science. They must be developed by several methods. Actually, I am going to mention some of them here. Dusting with fingerprints by using dusting powder and brush, and by chemical treatments by fuming with fumes from burning iodine crystals or fumes from cyanoacrylate, which is also named superglue and superglue technique. It's also a very common technique. Or by any other means, by drawing out the prints and making them visible. So the purpose here is to make invisible latent fingerprints make visible. For collection, by photographing or transferring to a transparent tape or similar substance. Right, these are some examples of latent fingerprints that are developed by using one of those methods that are mentioned here. Again, some samples of latent fingerprints. Right. Latent prints, they have to be developed. And what about life expectancy, which is a question that might be coming? It's not an easy question. The answers are here. When left on glass and other smooth objects, latent prints can remain for years if they are in a well-protected location. So this plays a critical role. I actually put this in red at the bottom of the slide. Environmental conditions play critical role. In coming slides, we're going to speak about the fingerprint residue that is left on the surfaces that we touch, and the composition of this residue when it comes in contact with water, for example, or some other conditions that comes in contact with this residue. In other words, are the fingerprints that are deposited on certain surface will affect the life expectancy. So if an object, for instance, is in an open air, prints can be developed several months. But again, the conditions are important after they are made. Prints on paper are extremely stable and will last for years if the paper does not become wet and deteriorate. Okay, this we will speak a bit more when we come to the surfaces. All right, we have done the second type is visible fingerprints. There are the prints of fingers or feet that are contaminated with foreign matter, like It may be a paint or blood or some other substance. And they don't need development because they're already obvious on that surface. They may be found in dust or blood or on any smooth and flat surface the suspect may have touched with. Visible print impressions are prints contaminated by foreign matter like blood or dust and made visible. Life expectancy, fingerprints that have resulted from contamination of the fingers with soot, dirt, floor, face, powder, etc. are soon destroyed. For obvious reasons, they will fly away. Fingerprints that are contaminated with blood, ink, pigments, and oil are more resistant and can last for a longer time under favorable conditions. Again, I would like to underline the conditions are critical here. Right, plastic fingerprint impressions, they occur when fingers touch or press against a plastic material in such a way that an impression of the friction-rich pattern is produced. What are they? They're usually found in a soft, pliable substances like a wax, soap, butter, or grease. So the plastic prints can also be found in paint, on a newly painted object, in the gum, for instance, on envelopes and stamps, on adhesive tape, and on substances that melt easily or soften when they are held in the hand. Okay, what about life expectancy? These prints can remain on an object for any length of time, provided that the object on which they are left or the substance in which they are formed is itself stable. Again, the conditions coming in contact with air and water plays a critical role. Right. Recording fingerprints. That's another topic in our webinar. So we have criminals, and then we have a bunch of people that we call them suspects, and we need to record their fingerprints. This is what we call tamprint form, TP. Yes. In this slide, again, you're looking at a tamprint form. 3 types of impression on a fingerprint card, tamprint form. So as you can see here, this is the operator or officer who is taking the fingerprint of the suspect here. I'm saying this suspect because we are mainly talking about this webinar. The purpose of the webinar is legal purposes. In a minute, I will talk about another type of fingerprinting, which is not the main topic of our presentation, which is the civilian database. We'll come to that. So the person, there's an ink pad, and by putting ink on the finger of the person that is being fingerprinted, then the fingers are put here, the image of the fingerprints are put here. These 10 are 10 fingers here. So these 4, I mean, this section here is just to prevent confusion. Here it says which hand, left or right. And these are four slap, what we call them slap fingers for control purposes. And this is the right. And these 2 are the thumbs of the person being fingerprinted. All right. Well, with the development in technology, I don't want to say no longer, but it's becoming less and less. The inked system is being used. So we have a system called live scanners that is used for digitally scanning fingerprint impressions and forming a digital file. As you can see, there are two different live scanners here. The fingers of the person being fingerprinted are put on the platform, and it simply scans the rich characteristics of the person and then forms a digital file, which is later on used for comparison purposes. Right. Okay. We came to the hot topic, the patterns and classification of fingerprints. Well, from the beginning, we said that a fingerprint is unique, but what makes them unique? Right. Well, this in this photo, you're seeing some numbers starting from 1, 2, 3, going up to 16. And then here, you're seeing each number is matched with a certain characteristic here. Right. So this is the structure of a friction skin. What I want to mention here is first, you see the sweat glands here. It's deep in the skin. It tells us that even though there is an accident or a cut in the finger, because the ridges are deep down in the skin, they will grow in the same shape. And here you look at the pores. Pores are little holes on our fingertips that actually are releasing a liquid called fingerprint residue. And then when we touch a surface, the shape of our unique fingerprint will be deposited on that very surface. Okay, another section, cross section of friction ridge. 2 here is the pore that the fingerprint residue, fingerprint liquid is released. All right, among others, I am going to share with you only 3 basic fingerprint patterns. You might hear at different places some different patterns. They are actually sub-branches of these 3 main patterns. Arch, this is the arch here, and then we have loop pattern. This is the loop pattern here, and then we have the war pattern here. So again, I put them here. When you look, you're going to see like the arch shape here, and then we have the loop pattern here. I'm not sure if you guys are able to follow my red dot here. So it is the loop, and these circle shape pattern is war. Right. So what makes fingerprints different? The terms: bifurcation, divergence, focal points, pattern area, point ridges, and shoulders. Right. This is what we call is a delta in the finger. So each of these lines, please accept them as the ridges on the fingertip. So delta is the first ridge or part of the ridge nearest the point of divergence of the type lines. And the core, as you can see here, is the approximate center of the finger impression. Okay, so this slide shows the characteristics with their shapes. Bifurcation here, this is what we call a lake, and this is an independent ridge, dot or island. This is a spur, this is a crossover. All these characteristics are different in every person and every person's fingerprints that enables us to classify them and make identification. Okay, another example, rich characteristics. Maybe I can, yeah, make it a little bigger. Yes. So you can see a crossover here. This is a core here. You see a bifurcation here that the ridge becomes 2 here, and we call it a bifurcation. As you can see, there is a island, what we call here, ridge endings, and then delta here. Oops. Okay, as I said in the first slides, also palm print impressions are possible to classify and identify. Just a short information on them. We are dividing the palm into sections, 1, 2, 3, 4, 5, 6, and 8. Flanax, any of the bones forming the fingers, these 3 we call them flanax, and then we have the digit, a finger or toe, and then interdigital area 5, 6, and 7. Right. Yeah. And then we have hypothinner area, and then we have thinner area marked as 4. Better photos are coming. Yeah, interdigital area. This part on the most frequently rich arrangements are deltas and loops. On very rare occasions, some whorls could be found. Just at this point, I want to mention that there is no standard in fingerprint science. I mean, in that you're going to, let's say, on the thumb, you will see loops or whorls. It can be many different shapes. There are sometimes fingerprints called accidental fingerprints, very, very different characteristics can be there. Okay, this is hypothinner area. Okay, I think this shows it better. Interdigital, hypothinner and thinner area. Just by looking at the segment here, you see the ridges, and then a term, infamous term, minutia. What is minutia? If anybody knows, you can type here in the chat section, and I promise I will read. And then we have the pores here. You see? Right. Let's continue. Okay. Ending ridge. We already had a look. The bifurcation. A clear view. That's a dot. And areas to be considered. Okay. And this is the core part, an approximate center of the pattern. So what do fingerprint scientists do? They take the core and then the delta here, and then they're going to make counting. For instance, from this delta point up to this core, there will be 1, 2, 3, 4, 5, whatever the number. That is going to help them identify a certain fingerprint. Yes, as you can see here, the first count, and then it continues from there on. Yes, identification through comparison. In this slide, you're looking at the numbers. Maybe the numbers. These are the numbers of the characteristics in that particular fingerprint under examination. And it can be a dot, a bifurcation, a spur, or a bridge, or the counting of the ridges. Right. So how do the comparison make? We have, I'm going to share with you that there are two types. Actually, it's manual and automated comparison. This is a very handy tool that fingerprint scientists or examiners are using. It is called Loop. Loop. It's basically a magnifier that helps the fingerprint examiner to magnify the fingerprint that he or she is examining. And then by using these pencils, he or she counts the marks, the characteristics. Okay, remember our inked fingerprint that we have taken on the thumbprint form? And this is the comparison. Right, here we see the numbers. There's number 14 here, which means not necessarily all, but marked characteristics are 14 here. So okay, we will come. How many minimum numbers do we need, or does a fingerprint expert examiner needs to conclude that it's a match? Please keep that question in your mind, and we're going to answer that before the webinar. All right. Again, I'm kindly asking you to recall our latent fingerprint that is recovered from a crime scene. So it was, remember, it was invisible and made visible by using physical or chemical methods, which could be a dusting or chemical fuming. And this is a latent fingerprint developed at a crime scene, and this is an inked fingerprint showing the rich characteristics that are identical in each of them, which is proving a match. Okay, it's a manual comparison. Points, same points. So, in other words, we have a known sample. Where is the source? What is the source of this known sample? It is the suspect. Now we have the suspect. Let's say there's an armed robbery, and we have 3 suspects, and then we take their fingerprints. Of course, with the necessary permissions have to be taken and all. I'm not going into that area. So we have the people that are inked or automatically taken fingerprints. And then we have the fingerprints that are coming from the crime scene, the latent fingerprints, or it might be a plastic fingerprint, or the other type of fingerprint. Remember, we have a suspect, let's say he kills the person, and then his hands are bloody. Actually, I've seen some crime scenes like that. And then he's trying to switch the light off and on, and then you're going to see bloody fingerprints on the switch of the electric. So this is from the crime scene, and then we have this known fingerprints, and then we are comparing them. Right. Okay, this brings us to the next point, which is comparison by computers. With the advances in technology, softwares have been developed to make comparison by computers. These are the images of fingerprints that are put into the system. Right. The name of this system is AFIS. AFIS stands for Automated Fingerprint Identification System. When we talk about AFIS, we talk about a database, actually. In this fingerprint database, it depends, I mean, it varies from country to country. It can include millions of fingerprints. And then there are sub-databases under that. which is, okay, look at this fingerprint, for instance, here, and these red dots here. Let me just red dots. Excuse me, the green lines here. They are the minutia points that are marked automatically by the system, AFIS system itself. And how is the comparison made by AFIS? I'm just going to share it with you. Okay, this is the functional configuration of a system. There is a fingerprint image scanner. Basically, when you have a latent print coming from the crime scene, it has to be taken over in a tape or photographed. So the image is scanned and put into the workstation. There is a processor and database, and then we have the matcher here. Yes, this is the fingerprint scanner. What we call this is an AFIS workstation. This is the CPU, central processing unit. And then when we have latent fingerprints brought on a tape, and what I mean by this, and I'm going to show in the next slides, when we have the fingerprints developed and put onto a tape, this is an image, this is a scanner here. This is going to scan the fingerprint and then put into CPU. The operator are going to look at the images on his or her screen. Right, what we call is the minutia points are marked by using algorithms. An algorithm works behind this system. It basically recognizes the characteristics. Remember, we had the ending, we had the dot, we had the bifurcation. It's going to mark those points on a given or examined fingerprint. And then what makes is it gives a score to each candidate retrieved from a fingerprint database. An example, let's say we went to a crime, the forensic technician goes to a crime scene, and I would like to underline here, properly documents the fingerprint, that this particular fingerprint is taken from that very crime scene with all the documentation methods that we just discussed in the first webinar, taken and brought to the laboratory, scanned and put into the system. This is an unknown fingerprint. We don't know whose fingerprints they are. So we put this into the system, and the system scans all other database. It goes through other fingerprints that are already in the database, and then gives scores to candidates. So what it makes is brings a list of candidates. At the end, it is still the operator that has to conclude that it is a match. What AFIS does, it only eases the process by looking at thousands, I mean millions of fingerprints, and brings you the candidates. Usually it may or may not be the highest scored candidate is the match. It may be the second, third, or maybe even later. Another point to mention here is searches are made through databases. Please recall our 10-print forms, and we have a database called 10-print database. Those 10-print databases are formed by taking the 10-print form, the 10-print inked fingerprints. What the operators do, they scan those fingerprints and put them into the AFIS database. And then the second type of database is latent print fingerprint database. What is the source of latent print database? Crime scene. Yes. So the crime, when the technicians, when they go to the crime scene, they develop fingerprints and then recover those fingerprints, bring them to the office, to the AFIS system, and then put them into their database that forms the latent print database. So when a search is made in the AFIS, four different searches are made. One, from 10print to 10print database, from 10print to latent print database, from latent print to latent print database, and from latent print to 10print database. It may be the situation that you bring a latent fingerprint, which I abbreviated here as LP. A latent print coming from the crime scene is scanned and put into the system. A search is run in the latent print database, and if it's a match, what it means, what's the meaning of that? It means that the same person committed two different crimes, or more accurate to say that the fingerprint of the same person is present in two different locations under investigation scenes. All right. A latent finger to thumbprint card with common points selected by user. So what this is a screen. It's actually a software. It allows the operator to take the mirror image to make it three-dimensional. So there are features that enables the operators to make a match. Right. Okay. AC-V method. This is an acronym for the scientific examination method: analysis, comparison, evaluation, and verification. It's commonly described as the scientific method that latent print examiners use to perceive detail in both known and latent prints and make decisions based on observations. Right. Earlier, I mentioned about minimum points on a fingerprint. So a few words about that. Some countries are still using minimum point requirements. In the past, let's say decades ago, minimum point requirement was 16. So it means if you can find matching 16 characteristics from an unknown print and from a known print, then you could only call this a match, a positive identification. Later on, in some countries, it became 12 points. This method, AC-V method, is a more trending method. It does not require any minimum points. What it makes is it leaves an expert opinion by using AC-V method. So what it makes is analyze the fingerprint, compare it with the unknown one, and then come to an evaluation. It's a match or not match. V is repeating of the first three steps, ACE, by an independent expert. And verification is this step. If they come to a conclusion that it's a match, then it's a match. If they don't come, and then it goes to a third examiner. This is a method that is in trend, and it is widely and more being used by fingerprint examiners. It changes from country to country. Okay. Yeah, and our final point is techniques to develop latent fingerprints. Again, not detailed, not too much technical. The reason I mention this is when you receive a police report, a forensic laboratory report, you may read as this paper or this file or whatever the evidence is found fingerprints, and the fingerprints are developed by using this method. So just to make you familiar with the terms, I'm going to share you quickly these fingerprint development techniques. Okay, please do recall the dots here and the pores, and this fingerprint residue that is coming out of the pores are deposited on the surfaces that we come in contact. And this is an important term here, latent print residue. It is the composition of fingerprint residue is 98% water, sweat, perspiration, salts. 1% is amino acids and 1% oils. It is formed on the friction ridges of fingers, palms, and feet. These materials are left on the surface contacted. And what we do as forensic scientists, we use chemical and physical methods to make those fingerprint residues that are left on the surfaces visible. Organic and inorganic constituents. Organic constituents are proteins, amino acids, and etc. The reason I put this here is, remember I told you chemical methods and physical methods. So proteins and amino acids, for instance, the techniques that are used by fingerprint experts are used, and then a chemical reaction happens, causing a color change and making the invisible print visible. Okay, these are the organic, porous and non-porous, two types of surfaces. It is important because in order to determine which method to use, we first look at the surface type, the surface that is fingerprint deposited. Okay, non-porous surfaces, these are mainly smooth surfaces of which the latent print resides on the surface. Examples of non-porous surfaces include glass, plastics, metals, and varnished wood. Latent prints on non-porous surfaces tend to be fragile, so they must be preserved as soon as possible. The primary technique is to expose the non-porous surface to superglue fumes, cyanoacrylate ester. What happens is superglue, it reacts with moisture present in the latent print, the fingerprint residue, converting the latent print into a hard plastic and bonds it to the surface. And porous surfaces, these are the surfaces of which the latent print is absorbed into the material. Examples include paper, cardboard, and untreated woods. I'm going to share with one simple and widely used approach to understand whether a surface is porous or non-porous. Imagine a surface, if that surface allows penetration of water, then we call it porous surface. If it doesn't allow penetration of water, then it is considered as a non-porous surface. So various chemical treatments are used to develop latent prints on porous materials. The chemicals target certain components present in the latent print residue. Remember the constituents in the fingerprint residue. So in time, scientists have worked on which part or which constituent in the fingerprint liquid or residue, the reaction. So this, for instance, here you see is an image of ninhydrin method, which is commonly used method for developing fingerprints on paper. Another point I want to mention here, paper and porous surfaces are better in terms of keeping the fingerprint because of the porous nature of the surface. The fingerprint residue is going to be kept better on the paper, in other words, porous surfaces. Right, another technique and type is sticky site powder. Sticky site powder is used for developing fingerprints found on adhesive surfaces, leaves a black print that can be photographed easily. Not sure if you can see, but there is a fingerprint here developed by using sticky site method. Okay, famous fingerprint powders. They're commercially available. By the way, these are just this is company name, but there are many different companies. Don't take it as an advertisement of any company. This is a fingerprint powder. These are brushes, commercially available in a variety of colors and textures, lightly applied to non-absorbent surfaces with camel hair brush. There are different types of brushes. I'm not going into detail. There is magnetic brushes and powders as well. Black, white, and gray for photographing on surfaces produce contrast. The reason why there are different colors is obtaining maximum contrast. Let's say if you have a white surface, then what should be the color of powder that we are applying? Maximum contrast is going to be given by a black powder and vice versa. So the different types of powders are for that purposes. Developing latent prints, the equipment used. Right here, please pay attention to this. These are tapes, what we call tapes. Once the fingerprint is developed at the crime scene on a surface by a fingerprint examiner, and then the first thing to do is to photograph, to capture the original image before trying to put it onto the tape. Why do we need to take it? Because we are going to use it in our AFIS system, remember? The photographs, the photograph images can also be used in AFIS system. When it is, of course, the numbers and scales and everything, it should be there, as we mentioned in the first webinar. These are the tapes, and these are different brush and powder types. Just showing an example on a surface, brush and fingerprints are developed, and then by using this tape, the fingerprints are transferred onto this tape and brought to the office, to the AFIS. Non-porous development, these are some samples here. This is glass, and this is polyester and aluminum, other type of non-porous surfaces. Again, with the advances in technology, there is a alternative light source, ALS. You might have hear them. You might hear them. They are used to make invisible fingerprints visible, and after fingerprint development technique is applied. I'm not going to go into detail, but the idea here works is to make invisible print visible, basically. So this is what we call a chamber. Cyanoacrylate is a chemical name for super glue. And yes, it is the simple super glue that we are using to stick our broken items at home. What basically happens is that it vaporizes there are hot plates that are used on this chambers. It basically vaporizes and then sticks to the to the fingerprint residue if it is present on the evidence item, in this case a gun. Water is used to humidify the environment, which it makes it easier to stick. Ninhydrin, which is a common method on amino acid regions, it can be applied to porous surfaces in a variety of solutions to develop latent finger and palm prints. The amino acid in fingerprint residue, it reacts with the amino acid reagent and then yields a purple print. Yes. Okay, that concludes my presentation. Here are some recommended reading. I guess the presentations will be shared and you will see them here. Handbook of Forensic Sciences, and this is a PDF document. It's free, National Criminal Justice Service publication. And this is the case that I mentioned, that Judge Pollack's decision, and then he reverses his decision about fingerprint evidence. Yes, that concludes my presentation. Thank you all for attending. And now we're ready for the questions section.
Yeah, thank you so much. And I want to say that I got a lot of information out of your presentation, and I really appreciate that. We're getting some questions from some of our participants, and we have about 10 minutes. I want to start with their patients with the same question that I asked you on Sunday when you were talking about crime scenes. Most of the people in our audience are defense attorneys, and I'm wondering how would you advise them to attack fingerprint evidence, to look at it critically in a way that would benefit their clients?
Yeah. The first item I would recommend to check is the documentation. By that I mean the paperwork has to show that that particular evidence, whether it is a footprint, a fingerprint, a weapon, a knife, whatever the evidence that is being presented against the accused, has to show proper documentation that is recovered from that particular crime scene. This is going to be my first advice, the point that I would look if I'm the accused. In terms of fingerprints, I would look. There are cases where we need to have a match, or sometimes an elimination purpose may also serve for our cases, for our purposes. What are, I would ask how that particular expert came to the conclusion that it's a match, or it is not a match. Obviously, I don't know the legal system over there, but experts in my country and has to come to the court and testify how they came to this conclusion. whether it's a match or not match. And then, which method have they been using to develop that fingerprint on that particular evidence? I think these are the first answers that come to my mind.
Okay, and we have a couple of questions on the screen. Let me just ask one quick follow-up question, and then I'll let you take a look at those. Is it possible for fingerprint experts to make a mistake in their identification? And I guess this is related to my last question. How would a criminal defense lawyer probe on cross-examination to see whether mistakes were made?
Yes, it is possible to make a mistake. The AC-V technique that method that I mentioned during presentation is actually devised to make sure that there is no mistake, because of the importance and uniqueness of fingerprint evidence. It just one fingerprint may put a person in jail for lifelong, or make a criminal free, causing danger for others in the society. So it's critically important just to make sure there is no mistake. They are what is the right word here? They can be examined by third examiners, for example. Since you have one unknown a latent print coming from the crime scene, and then we have the database and known fingerprint. The claim is that it's a match. So if it's a match, and then another expert, an independent expert, or an laboratory should be able to confirm the match.
So I think that we have a fellow CSI watcher with the first question that's on the screen, and there are three questions there. How long will fingerprints last on non-porous surfaces roughly? I guess that's just one question. But the second part of the question I really like, because we see on television people trying to use sandpaper to get rid of their fingerprints, or using glue, or cleaning crime scenes with chlorine. So I'm wondering if you could address ways that a suspect might be able to manipulate fingerprints to escape being caught, and if those things that we see on television really work.
Suspect could manipulate his fingerprints in crime scene in order to escape from us. Okay, let me start with the first part. How long the fingerprints will last for in non-porous surface? I give great importance on that the conditions part. The moisture in the environment, rain, or other conditions will have a critical part. If in the question there is no other means to deteriorate or if the fingerprint is kept as it is, I'm going to mention like a month it can stay. But in this, if there is a question in hand, then a test run will be helpful. If actually the same is done when we are developing fingerprints, let's say this is evidence that came from the crime scene, because it's a glass. As a test run, I leave my fingerprints on a test paper or another known surface, which is going to show that my environment, the conditions of my environment.